Hello everyone, I wanted to show you a conversion I did on my Rockwood mini light 2104. I converted the sealed lead acid batteries, I think they actually might be gel, I'm not even sure, to lithium. And I did that for a few reasons. One is I wanted to power my rooftop air conditioner for a few hours without any main electric at all or generator. And I also didn't want to leave the batteries out here in front because I didn't want to get them stolen. So what I did was I bought some welding cable. I think this is 2/0 or 1/0. And I basically ran a positive and negative from inside the compartment here underneath the RV. Kind of see it coming out here. And I ran it into the battery cage where the old batteries were. And what I did was I connected them to the existing spot where the battery would go. So in other words, the battery was connected to here and here. And I had two batteries. So it gave me a little bit more power than just having one up here. But I didn't want to relocate anything, and I didn't want to redo any of the wiring. And the reason why this wiring here is good, I don't have to upgrade it, is because this just would have serviced whatever 12 volt appliances that it was already servicing. Okay. The important part of this and why I needed these huge wires really was for the inverter. So bought myself a xantrex pure sine wave 3.0 inverter. And even though this inverter is not for lithium, it is configurable to make it work with lithium. So in other words, you can set the charging voltage, the max charging voltage on that inverter charger to be at 14.4. I think there's 14.2. There's quite a few options you can choose. And it just so happens to be that 14.4 is the optimal setting for my lithium battery. So I went with 4 lithium batteries, and I did a review on these batteries a while back. Each battery is about 105 amp hours. So I have, give or take, about 5,000 watts at 12 volts. I also have a Victron Smart Shunt that I have connected up to it so that I could observe the amperage going in and out. So you can see right now the batteries are sitting at 1311. There's no current going in or out, and I've used about 186 amps out of a possible 400. So the battery is about half used, and the reason why it's half drawn is because I'm not using the travel trailer right now. So they don't recommend leaving LifePo batteries fully charged. So that is another reason why I did not want to charge them up fully while this thing's just at rest. So I do not have this plugged into the house right now. It's plugged in, but when you follow the cord is unplugged right now. So what I'm going to do is turn the air conditioner on. So there's a couple things to make this system work. I do have a soft starter up on the AC, so it makes it easier to start. And the reason I really did that was for using my generator. It really wasn't for the inverter. The inverter should be able to handle that surge, but it does actually make it easier on it. So what we're going to do is just go ahead and give this a start. So we'll turn this on, we'll set this to it's about 78 degrees out today, so we'll go ahead and turn this on cool. And what we're gonna do is come down to the console here, and we gotta do two things. We gotta turn the inverter on, and then we also have to turn this master switch on. So this is fused as well. There is a fuse, and this is my master switch here. Now the cool thing about when it's off, so when that's off and when that's plugged in, because it's an inverter charger, it will run any 12 volt appliance that I have in here. So I technically do not even need to be have it set to the 120 volt mode. I could just have it running 12 volt when this is off. So it's pretty convenient feature. But we're gonna go ahead and turn this on. And we'll come over to the console of the inverter, and then we're gonna turn the inverter on. And then what should happen here is the air conditioner is gonna come on. Now, I just heard it kick on, so it's probably fan only. And it usually takes a second. So I think I just heard the compressor come on. So we'll see if the compressor is on by looking at the watt draw. So right there, you can see it's drawing almost 1200 watts. Now this is a 15,000 watt BTU, so it will draw about 1400 watts, 1400 to 1500 watts. So you can see right now that it is using 98 amps. The batteries are sitting at 1267, and this time remaining is a little inaccurate. The way to figure that out is you would take 1400 watts and you would divide that by 5,000 watts, which is the total amount of watts that the batteries are. But then you also have to factor in that the air conditioner probably is not going to be running full time. It might be running 80% of the time, 90% of the time. But give or take, it should go somewhere around 4 hours. And you can see right here, it's already dropped to 2 hours and 52 minutes. And the reason I went with that inverter there was because it's an inverter charger. It's pure sine wave. It will charge my lithium batteries as I need, and it also is a 3,000 watt inverter. So what I did is I took the line, as it comes in from the RV, the AC line, and it comes into this panel here. And so what I did was, instead of leaving it into the panel, I actually ran that line to the inverter. And then I ran it from the inverter back to this panel here. So what that allows me to do really is let the inverter control everything. So that means I do not need the mains power as long as I have battery. So I could run my air conditioner. I could run appliances in here. Now, because it's a 3,000 watt inverter, technically it should run that microwave while that's on. Now, I haven't tested that, but we could do that now. But I just want to kind of go over here and kind of show you what I was talking about. So you're going to see right here, there's two lines that come in. One's coming in, and just think of that coming in from like household electric. That goes into the inverter, and then back out of the inverter goes into the control panel of the RV. Now, one thing I also did was I disabled the onboard converter. Don't get confused with inverter and converter. But this here is my converter, and you can see I have that disabled. Now, the reason why I left this converter on is in case if I ever needed to use it. It's a little bit dangerous by having it on, because in theory, if I turned it on, it would be basically doing the same thing my charger inverter is doing. So it kind of would be really wasting electricity. So best practice probably would be just to either remove the fuse and or turn this off. But you can kind of see I have no use for that right now, really. All the conversion, all the 120 volt conversion is being done by my Xantrex pure sine wave charger inverter. So over on the inverter, you can kind of see a little bit of details about what it's using. So it thinks it's sitting at 12 volts and it's using 120 amps. Now, again, this is running at 12 volts. So if you took 120 amps times it by 12, you'd get the approximate wattage that we're seeing over on the Xantrex. So what we're gonna do, just as a test, and I haven't done this before, it's a 3,000 watt inverter, so it's already using half of that here. So what we're gonna do is turn the microwave on and see if it can run it. So you can see right here, we're pulling 1,500 watts. So that shows you that the air, and it's blasting out nice cool air right now. And again, I'm not connected into the mains power. I'm just running purely on the inverter. So what I might do, well, we'll just go over here and I'll hit the, I don't have anything in there, but we'll just go ahead and hit a minute and see what happens. Okay, that came on, and you can see now I'm using 3,000 watts, a little over 3,000. So I'm going to shut this off only because just wanted to show you that it would work, and then it drops back down to 1,500 watts. So it was going over a little bit over what the inverter's rated for. It's rated for 3,000 watts, and I was pulling about 3,300 watts out of there. But in a normal situation, would I do that? I don't know. I might shut the air conditioner off while I'm running the microwave, just because I know how much they both draw and how much of a drain that is on the battery. What's nice about the inverter charger is that, you know, I don't need a transfer switch. So if I were to now plug this into mains power, what it would do is switch over. You see how the kind of charger's on standby there, and what would happen is provided the source, in other words, the incoming amperage, and you can configure that as well, you can dedicate however many amps you want to charging versus running your appliances. So in the AC mode, when it's converting, or I should say when it's inverting the power from DC to AC, you can tell it how much to divert that to charging your batteries. So if you only have a 15 amp circuit, right, that's basically, let's call it 17 or 1800 watts for all intents and purposes, and you know that air conditioner is going to be running 15, that only gives about 200 watts for charging. So why that is important is you won't blow any fuses. So you can control this thing. Like, you can tell it, hey, I'm running on a 15 amp circuit, I'm running on a 20 amp circuit, I'm running on a 30 amp circuit. So then it knows how much juice to try to pump back into the batteries. And the batteries are configurable as well. I think it goes down to 50 amp hour battery. I want to say all the way up to maybe a 4,000 amp hour battery. And what that algorithm's really doing is controlling how long it should stay recognized as well when it gets to that 14.4. But once it jumps out of that bulk stage, it goes into absorption, and that's really the purpose of telling the inverter how big the battery is as to for how long it'll stay in absorption. And then of course it can go into float as well, and there's a float setting that's very, very close to, I didn't want to say 13.5 or something, which is very close to what this particular brand of lithium LiFePO battery is. So as I said, the inverter is highly configurable in that way, and you can also disable the temperature compensation. Like a lot of you old schoolers know that the lead acid batteries, depending on whether it's hot or cold, would determine if it should have extra charge or lesser of a charge, depending on if it's hot or cold outside. And with this inverter, you can shut that off, because that really doesn't apply to LiFePO. You set it to 14.4, it's going to charge to 14.4. It's not going to do any compensation if you program it that way. So I just thought it was a viable option instead of the Victron series. I know Xantrex are very stout inverters, and which is one of the reasons why I chose this particular inverter. So you can see, I don't know, we've been going on here about 10 minutes now, trying to get that in the light for you the best way. There you go. So you can see it's air conditioner's still still blowing nice and cold air. You kind of see we're running 1600 watts, give or take, right there. And what I'm gonna do is plug this in. The transfer switch in the inverter should switch. In other words, hey, it knows it's running on AC. And what should happen is the AC mains will be put. You know what? Let's just see what we can see with the voltage is, because I have a little thing here that reads the voltage. Okay, so it's sitting at 115. I'm sure that's going to be slightly different when I plug this in. So it's plugged in now. So let's see what happens. So the air conditioner is still on. So now it's 108. So kind of see now the inverter is not using any battery, because it's now coming from, instead of coming from the battery, instead of inverting it, it's now in bypass mode where it's coming from the house. And I'm sitting at 108 volts. You see the voltage difference because I'm using a relatively cheap extension cord that's running from all the way over there, up there, down. And I think that's a 15 amp cord. So it's probably not the best cord to be using for this experiment. But that was just proof to show you that it's now running on the AC bypass mode. And again, I can't remember, we're going to show this in a second because I'm going to shut the AC off, but it should start charging. I can't remember what I have it set for, 10 amps, 15 amps, whatever. But so right now the battery really is doing nothing. It's not charging. I'm going to shut this off and let's see what happens here. Okay, so now the AC is off. Now you can see it started charging the battery. See how we now have a positive 800 watts, 900 watts, 1000 watts. And this is programmable as well. I can't remember what I have the max set for, but I want to say that max charging is 120 amps on this. And I don't remember if I have it set for 100 amps, 90 amps. I can't remember, but let's just watch it and see what it does. I probably should have had that data available. I want to say I had it set for 90 amps. I don't know. I'd have to look at the dip switches, and probably should have took a picture of them before I put it in there, because the dip switches are on the side of the box. But you can kind of see right now, charging up the batteries, charging it. So yeah, it's 90 amps. So I have the inverter set to 90 amps. I could set it to 120, but the reason I didn't is because of the line that I just showed you. I don't feel comfortable with that running, over 1500 watts with that long line. So I believe I have it set for 90 amps. But again, it's going to charge these batteries. If I was running 120 amps, it would charge them in a little over 3 hours. Running at 100 amps will probably take 4 hours. So it's not a huge difference. Even at 90 amps, it might take 5 hours. I don't know. But I wanted to err on the side of caution here. But like I said, there are settings on there where I could set this to, bring in 1500 watts and then take the remaining a little bit and charge it over, let it charge the batteries. I'm trying to see if I had something that drew just a little bit of electric in here. This obviously uses, I think, more than the AC. But I don't have like an AC appliance in here where I could draw like 500 watts and then show you how it's using 500 watts on the mains, but then also, charging the battery. So you can see that voltage to me is kind of low, and I really do need to get a better, probably like a 10 gauge extension cord and reroute a 10 gauge extension cord up there. I can't remember. I want to say that's a 14 gauge extension cord. But anyway, the main things I wanted to accomplish was with this conversion is I wanted to go to lithium batteries. I also wanted to not have them be stolen so easily, so I didn't want them sitting out there in the tongue of the truck. Plus, I didn't want the weight up there either. Granted, these batteries weigh less than the sealed lead acids or the AGMs or gels, so weight was an issue, but more the security really was the big issue. So that is how I end up doing this conversion. Again, it was relatively simple. The first part I wanted to focus on was my inverter charger. And I think, if you're looking for something and you're getting into this, you probably want to look at the Victron line. I think they have a multi-plus that is right around 3,000 watts. It's an inverter charger. It does lithium batteries out of the box. But the key here is where that main comes in. So you have to think about it, where it comes into the so on the outside of the RV, where you plug your house power into, that normally comes into here. I rerouted that. I basically disconnected from there, and I ran an extension over to where the inverter charger is. Then I came back and wired it back in there and shut off the converter. Now, a lot of people will remove their converter, but I would argue there could be a case if my inverter charger blew up and I needed to, when I was out on the road and I needed AC, I could just easily hook that converter back up and still kind of be back in business and charge my, run all my 12-volt appliances through that converter there. So hopefully that kind of explains how I did this to everyone.